Hello, everyone. Again, give me 1 second. Let me stop the audio from this streaming computer. All right. All right. Hello, everyone, and welcome to the seventh edition of Grandstream Tech Talk. My name is Abdel Jabbar. I am a support engineer with Grandstream Networks. I am glad to host today's session about Tech Talk, in which we will go over the most popular subjects for the last 3 months. As you might know, every quarter, Grandstream sends a survey to our customers to choose a topic that you would like us to include. So based on the last survey we did, these are the three top chosen topics. Let me go back here for a second. So the first topic is about the Grandstream provisioning methods that are supported by Grandstream endpoints. And the second one is fax configuration using HT8xx series. And the third topic is the hybrid work from home. And especially a lot of customers they were asking about the recommended settings when they use the phones remotely or when they bring them back to the office. So before we start our presentation, I want to mention that the recording of this webinar will be available on YouTube by the end of this week. And during the presentation, if you guys have any questions, please make sure to use the Q&A section, and we will go over them at the end of the presentation. So without further ado, let's get started. So the first subject of today's presentation is the provisioning options supported by Grandstream endpoints and how the provisioning process works. Because we keep still receiving a lot of requests how the endpoints work when using all these all these provisioning options together on the Grandstream endpoints. And in general, there are 5 methods of provisioning Grandstream endpoints. We have GDMS, gaps, zero config, config templates, and the use of DHCP options. So the first method to provision Grandstream devices is the use of gaps, and it is usually used for mass deployment and provisioning. And many ITSPs and large installers, they use gaps for redirection services. And basically the way gaps work, uh, by default, all Grandstream devices come with the config server path fm.grandstream.com, which points to gaps. So when the device in default settings boots up, it will automatically request its configuration file from gaps. And if there is a configuration preset or profile for that specific device, uh, gaps will provision the XML config file. And because gaps only allows the configuration of some of the main parameters, ITSPs and large installers, they use the generated XML file to redirect the devices to their provisioning platforms, which will include the complete configuration file. And this is done by pushing the config server path to point to their provisioning platform. And the provided URL or IP address will overwrite the gap's default URL, and the device will save the provisioning server information for any future provisioning requests. That being said, GAPS offers plug-and-play service. ITSPs and large installers can directly ship devices to their customers without the need to unbox them or pre-configure them. And all that is required for this scenario to work is to add the MAC address of the device to the GAPS profile. And one more thing about GAPS is that it is only available through our distribution channel. So if you would like to use GAPS, just reach out to your distributor to check if they can provide you with access to gaps. The second provisioning option available for the Grandstream endpoints is zero config, which is provided through the Grandstream IPPBX UCM 6000 series. As you might know, zero config is designed to work in a local environment and to provide plug and play method to auto provision Grandstream endpoints. And in addition, it offers auto discovery and configuration services for local Grandstream devices. Zero config on the UCM works this way. When a Grandstream device boots up, it sends SIP subscribe message to a multicast IP address that the UCM is always listening to. So when the UCM sees that there is a message on that multicast IP address, it will respond to the device with the default HTTPS link to use to request the configuration file. It basically overwrites the default config server path with the HTTPS link for zero config. And actually, it will only send the zero config link if auto configuration is enabled or if that device already exists in the zero config device configuration page. So zero config works only with Grandstream devices that are located in the same network as the UCM. You can use it in an environment where you have multiple like subnets or VLANs, and there is a way how to do that. Later we're going to go through that one. The third option is changing the config server path, either manually or through auto provisioning from gaps or option 66. So as I mentioned earlier, the default config server path on all Grandstream devices points to gaps. So in case you need to use your HTTP or TFTP server for provisioning and configuration, the default URL needs to be changed. And when dealing with few devices, it's fine to use the web interface or the phone keypad menu to change the config server path so that it can point to your provisioning server. However, when dealing with hundreds or even thousands of devices, that's when gaps comes in handy to change the default URL on the devices automatically upon boot up. And compared to zero config and gaps, which use graphical interfaces to create the configuration presets, working with the config servers or the config templates require creating XML or binary files using the supported P codes that you can download from the Grandstream website. Another method to provision Grandstream devices is through DHCP option 66, which is used to send the IP address of a TFTP server that contains the config file. When a Grandstream device boots up, it will get the provisioning server URL or the IP address during the exchange of DHCP messages. And the DHCP server needs to be configured with option 66. Then the Grandstream device would use the provided URL or IP address to request its configuration file using TFTP. And to use this method, you need to make sure your router supports the configuration of the DHCP options because not all routers have this capability. So when deploying many devices in the same network, passing the config server path through the DHCP option 66 could be very useful considering the overhead of manual configuration. And again, DHCP option works only in a local environment. So far, all the methods explained use the config server path to tell the device where to get the configuration preset. In addition to that, Grandstream devices support TR069 protocol for provisioning, which is a protocol used by GDMS. And GDMS, for those of you who don't know, is a Grandstream cloud-based solution. that allows you to provision, manage, monitor, and troubleshoot Grandstream devices from one centralized management interface. And GDMS is gaining more popularity compared to the other methods because it provides easy to use enterprise level tools to manage Grandstream devices before, during, and after deployment. It also offers the ability to plug and play for the supported devices, and there are many features and management tools built into GDMS. You can always go to Grandstream YouTube channel and watch the video related to GDMS. There is also a video guide for zero config in case you want to use zero config to provision devices on multiple VLANs and subnets. So when some or all these options are configured in conjunction, there is a process or an order that the device follows to complete the provisioning. The first method that is implemented during a boot up process is DHCP option 66. And that makes sense because DHCP requests are the first messages that any device sends when it powers on. And if option 66 is pushed by the DHCP server, the device will use that information to update the config server path and eventually use it to request the config file. After that, the device will send the SIP subscribe message to a multicast IP address that the UCM is always listening to. And if auto configuration is enabled for zero config, or if that device already exists in the zero config device configuration page, the UCM will send its zero config link to overwrite the existing config server path, including the one that was provisioned through DHCP option 66. So when using a specific device, zero config that you would like to reset to default, first make sure you delete the device from zero config before you initiate factory reset on the phone. Otherwise, zero config will keep provisioning the device every time it boots up in the same network, even if you press reset. And that's a lot of uh, I mean, that's something that we see a lot is like the customer, they complain that they reset the device and it keeps getting provisioned because if zero config has auto configuration or it has a configuration preset for that device, even if you do factory reset, zero config will still be able to provision that device. So if the UCM is not used or zero config is not enabled, the device will use the information in the DHCP option 66 to request the configuration file. And the same thing applies in the case where the device is manually configured with the custom config server path. So if none of these options is implemented and the device is in the default settings, it will use gaps to request the configuration file. Because as I mentioned earlier, by default, all Grandstream devices point to gaps in the default settings. So if there is a configuration preset for that device in gaps, the gaps will push the link for this config server path that the device needs to use to request its configuration. And that is what we refer to as redirection. It's like gaps doesn't provision the phone, but it just redirects them to the config server path to use. And as mentioned earlier, GDMS uses TR069, and it essentially does not interact much with the other methods unless the config file explicitly disables TR069, and that's when GDMS will not work for provisioning. So GDMS can be used in conjunction with the other provisioning methods, but there is a catch here. For instance, when using GDMS and zero config and both have different values for the same setting, the last provisioning will override the previous one. We can use an example with For example, we can use time zone. So let's assume that GDMS has Pacific time zone configured and zeroconfig has Eastern time zone. So for the same device, we have two different time zones. And the question here is which one will be implemented? And the answer is the one that is last pushed to the phone will be implemented. So it's basically GDMS when used with the other ones, uh, uh, the last configuration will be implemented. So let's log into one of the devices so we can look at these settings on the IP phone. So I have a GXP 2170 here, so let me log in quickly. And the configuration parameters for provisioning are located under maintenance, upgrade, and provision. So there are so many settings here, so we're going to go over some of them to explain what they do. So let's start with this one, 3CX auto provision. So as I mentioned earlier, when the phone boots up the first time, it will send that SIP subscribe message, which allows the UCM to discover and detect Grandstream devices in the same network. In case you want to disable this option, like you don't want the UCM to discover devices, you can set that one to no. If you are using zero config on the UCM, you definitely want to set that one to yes. The other option that we talked about is option 66. And this one requires that the router needs to be configured with option 66 so that the IP phone can override this default URL which points to gaps. And you have two options here. There is no in case you don't want to use option 66, and there is yes. And there's this option which is prefer fallback when failed. So the way the last option works is when you configure your DHCP with option 66, and then the phone would use that information to request the configuration. If there is a problem with that link that was provided through option 66, the IP phone will use whatever it has here under the config server path. And it's something that, as I mentioned, that you can customize manually. Some other options here, if we go under config, so these are the methods that are supported, TFTP, HTTP, or HTTPS, FTP, and FTPS as well. You have some options here with config server path, username, and password in case you have the platform protected with the username and password. And also there's the option here with config file prefix and config file postfix. Usually the phones, excuse me, the phones when they request the config file, they're going to use their MAC address to request the config file from the server. So they're always going to look for CFG plus the MAC address. And they use, I believe, three strings to request the config. One is very specific that includes the MAC address, and then there is the CFG.xml, which is global, and there is also the CFG plus the device model to request the configuration. And this is useful in case you have your own provision platform with different configuration files customized for each model. There's this option too with the XML config file password because for security you can actually encrypt the configuration file using OpenSSL, and then whatever password you use to encrypt the file in your provision platform, you need to include that password here so that the phone would use the password to decrypt the configuration files. Some other options here, we have download device configuration. So in case you want to copy this configuration to another device, you can use that one. So once you download it, you're going to get a TXT file that you can manually upload to another device. There's this option here, user protection. Sometimes like installers, they use zero config to provision the phones or the config server path. But the users, they like to customize some settings using the web interface of the phone. The purpose of this option, when it's set to off, Every time the config server path provisions the phone, it will overwrite the changes that were made manually. That's in case where you have like the same settings on both that were made manually or through a config file. In case you want to keep the changes that were made manually on the phone through the web interface, you can set this option to on. So even if zero config, even if you try to change it through zero config or config file using config server path, the phone will keep that information. It will not override it through zero config. This option here, download and process all available config files. So as I mentioned, yeah, I believe you can see it here. So the phone by default, they request the config file using multiple strings. They use the CFG plus the MAC address, then they use the CFG XML, then they use CFG model. So when you set this option to yes, the phone is going to request all these config files and implement them on the phone. And this is useful, as I mentioned, in case you have specific configuration file for that device, and then you have another template that you would like to apply to all the Grandstream of specific model. The phone will request its configuration file that is based on the MAC address. Then it will also request the configuration file um, that is created for that specific model. But in case you only have one configuration file, you can set that one to no. So once the phone finds a configuration file that it's looking for, it will implement it without continuing to search for the other configuration files. We talked about download device configuration. One thing about this option is that it does not download anything that has to do with personal data or passwords. For example, if you have the password here and then you download the device configuration, it will not include the password. It doesn't include the password for the login credentials, SIP passwords as well. So it does not include any information that is considered security or personal information. In case, for example, you have a phone that is experiencing issues and you want to switch it with another phone, there's this option here where you can export the backup. And when you export it, you basically export all the information, including personal data like call history, phone books, and all that information will be exported. Then you just go to the other phone and upload the backup on that specific phone. So this is regarding the configuration using the config server path. Regarding GDMS, as I mentioned, it uses a different protocol, which is TR069. And for the supported models, all of them, they come with the link that points to GDMS. So every time you reboot the phone, it is going to check with GDMS if it has a configuration preset. A few things to mention here. The connection request username. Sometimes when you take a configuration from specific device, then you upload it to another device, you might upload the MAC address of the other phone to the new phone. And if the MAC address changes and if the phone tries to request the configuration from GDMS, it's not going to work because it's going to be using a MAC address that does not belong to the phone. So always make sure that the device you are working with has the same MAC address that is included under network status right here. Just remove the delimiters like colon and then make sure it is added right here. So that's one of the things to pay attention when downloading and uploading configuration from one device to another. All right, so let's move on to the next topic, which is going to be fax over IP. So fax over IP using the Grandstream HT8xx series, which is designed for a situation where you need to connect analog devices to an IP network. And in our example here, we have an analog fax machine that is connected to an IP network for fax over IP. So when trying to switch from traditional analog fax to fax over IP solutions such as HT800, there are generally two methods that can be used depending on which one the ITSP or SIP platform supports. So we have T38 fax relay and PCM pass-through, and each one of them has different mechanisms for sending and receiving fax. So first, let's talk about PCM pass-through. So when you enable pass-through for fax on the HT800 series, it basically converts fax tones into PCM audio streams using the G711 codec encapsulated into RTP packets. And this is the process usually referred to as transcoding. And the problem with the PCM pass-through or fax pass-through is that it is not optimized for fax transmission over IP networks because it does not have a built-in mechanism to deal with network imperfections such as latency, packet loss, and jitter. And usually during a phone call, like with minor packet loss, the human ear can still fill the gap to recreate the lost audio. But with fax, any missing data or packet is significant because fax pass-through does not have any mechanism to recreate the lost packets, which leads to degraded fax image quality or high fax failure rate. And this can get worse when trying to send or receive a lengthy fax image of multiple pages. And this is why we always recommend using T38 method for fax because it is specifically designed for fax over IP and has a high tolerance to network imperfections such as latency, packet loss, and jitter. Plus, it supports data and control redundancy to mitigate the effects of network imperfections. And the only disadvantage of T38 that I could think of is latency that is caused by the transcoding overhead. And this can become significant when using multiple transcoding gateways in between. But when connecting the HT800 series directly to the fax server or the ITSP that provides fax over IP, uh, that should not be an issue because the HT800 series is designed with fast transcoding algorithm. And of course, before you enable T38 for fax, you need to make sure your provider supports T38 because not all of them support T38. So these are some of the recommended settings for fax when using the T38 on the HT800 series. So first of all, you want to set the fax mode to T38. There's an option that says use first matching vocoder in 200 KSTP. Set that one to yes. And when you set that one to yes, make sure that the preferred vocoder, which is choice number one, is set to PCMU. The reason why we recommend using PCMU because that's the codec that works better with fax. And sometimes, like some ITSPs, even if with fax, they might prioritize another codec. So you want to tell the HT to prioritize G711. There's also the option of reinvite after fax tone detected. You want to check that one to yes. And basically the way this option works, when the HT800 detects fax tones, it will send a reinvite to negotiate the media for fax. So this setting is important. The next one is the line echo canceller. So we want to disable that one because the HT might confuse fax tones with echo on the line. So we want to disable this option so that it does not cancel any packets on the incoming or the outgoing traffic. And basically, line echo canceller is a setting that you can enable to optimize the voice for like voice calls instead of fax. The other option that you can disable is call waiting, because if you have one line and the line is busy and there is another incoming call, the call waiting tones, they might be like they might create a confusion in the fax tone for the ATA, so it might interpret those call waiting tones as fax tones, and that eventually will cause the fax image to degrade, or probably you will get a corrupted fax image. Another important thing when using the HT with fax is make sure you don't use the phone line cord splitters, because sometimes when you use the splitter, the device will not get enough gain. It will lose the gain, or it will not get enough voltage to submit the disconnect signaling and all that type of analog signaling that is used by the analog devices. And usually there are some settings that are also required to be implemented on the fax machine settings. The first one being the bit rate. It's important to remember that the HT800 series uses V17 modulation standard, which requires um, the bit rates lower than 14,400. And basically, bit rate means the transmission speed for fax. So you need to make sure that the fax machine is adjusted for that bit rate. Some fax machines, they don't show the bit rate, but they might give you like a high speed transmission, medium speed, low speed. So you always want to start with the low speed, medium, and uh, and high speed is used for another modulation standard, which is V34. The second option is ECM, which stands for error correction mode, and it is a fax method that checks the integrity of the received data. And the way this feature works is that the sending fax machine will include a checksum for each block of data that needs to be verified by the receiving fax machine. And if the checksum does not match, it is an indication that the block of data has packet loss, and the receiving fax machine would request that the block of data be retransmitted. And without ECM, missing data would simply be ignored by the receiving fax machine, leading to some degradation in the fax image quality. And and from what I just mentioned, it sounds like it is an important feature to enable. However, ECM can increase the number of data blocks that need to be transmitted because the checksum because of checksum errors. And occasionally the fax will just fail when the maximum number of retransmissions is reached, which is usually 3 retransmissions. And this is very typical in a network environment with high jitter and packet loss. So ECM is usually required when using high-speed transmission, such as V34 modulation standard, which is not supported by HT800. And the V34 standard, they can use a bit rate of up to 33,600 bits. But since Grandstream HT800 series uses V17 modulation standard, it might be helpful to disable this option on the fax machine so that you can avoid issues with retransmission, especially in a network environment where you have high jitter and high packet loss. So let's log into one of the ATAs so we can look at those settings that we mentioned earlier. So I have an HT, I believe this is 813, okay. So the fax settings are available under FXS port. Of course, you need to configure the primary server, user ID, authentication ID, and the password. And the fax settings are located somewhere. Let's look right here. Okay, so the first one is disable call waiting. So you want to check this option, set it to yes, because we don't want to use call waiting with fax. As I mentioned, because the call waiting tones, they might get confused with the fax tones, and that can cause some degradation in the fax image quality. The other options that we can use is this one right here, use first matching vocoder. When you set that one to yes, make sure that the choice number one is PCMU. You can also set all of them to PCMU if you want, which is usually recommended. Now, when you do that, you prioritize PCMU and you make it the only codec to be used for fax. And at the same time, when you do that, you also reduce the size of the media message in the SIP message as well. There are some settings here that can be used to optimize G711 for voice, like VAD or voice activation detection. You want to leave that one set to no. We don't want to set it to yes. And fax mode, make sure you use T38. In case your provider doesn't support T38, you can always use pass-through. And when you use pass-through, just make sure this option right here is disabled, okay? Because if you enable this option with pass-through, when the HT detects a fax tone, it will send a re-invite for T38. So you want to set that one to disabled with pass-through. In case you are using T38, you want to set that one to enabled. In some cases where you are experiencing jitter, it could be helpful to toggle these two options here, but you don't want to go too high because one of the problems with fax or fax in general is very sensitive to latency. So when there is latency, there are problems with fax. And when you increase the jitter to high, you eventually or you automatically increase the latency. So you want to set that one to either low or medium and toggle these two options. The other options for, yeah, so we talked about this earlier, like echo canceller. So you want to set that one to yes because we want to disable the LAC. Also make sure that this option also is disabled. So anything that is used to optimize G711 for voice, we want to disable these options because we just want to receive the fax tones as they are. We don't want to make changes to anything in the fax tones. So once you make these changes, just save and apply the changes. And you should be all set to use the fax with the HT800 series. So let me go back to the presentation. So the next or the third or the last topic for today is work from home. We keep receiving a lot of requests to show how to use or how to configure endpoint devices for users who work from home. We did a webinar about that one, but we're just going to summarize all these settings in in today's webinar. So when you have a user that takes the phone, like brings the phone to the office, then takes it with him or with her home, uh, there is a setting that you can use for that scenario, and that is the use of primary SIP server and secondary SIP server. So in case you have such a scenario where the user keeps bringing the phone back and forth from home to the office, you can use the primary SIP server to the private IP address. Even if here I have the public IP address, it's always recommended to use the primary SIP server for the private IP address and the secondary SIP server for the public IP address. The reason why I would suggest to use the primary SIP server for the private IP because in some environments we have the what we call hair pinning. It's like the router works with the hair pinning. The phone will still be able to register using the public IP address. However, when you make calls and you receive calls, you're going to experience some issues with audio. So it's always better to set the primary SIP server to the private IP address and the secondary to the public IP address. So when the user takes the phone home, it will still be able to register to the UCM or the IP PBX in the office. Another option also to enable on the IP phone is registration expiration. Just make sure you reduce that one to a lower value. By default, it's 60 minutes. You can use 4 minutes depending on your SIP platform. By default, the UCM uses, I believe, 90 seconds as the minimum. So using 2 minutes should work with the UCM. Some platforms, they might have a higher minimum registration timeout. And if you reduce it below that registration timeout, the server might reject the registration with an error saying, for example, interval too short, because they use that mechanism to see or to detect uh, those SIP malicious attempt that send very frequent SIP requests to the server. The other option that you can enable as well on the Grandstream endpoint devices is the NAT traversal. So many times we talked about remote users. It's always recommended to use stun server, especially when you have a router that doesn't use symmetric NATing, because NAT stun in general doesn't work with symmetric NATing. But in case you have a phone, for example, like the WP820, which is a Wi-Fi phone that you can take home and bring back to the office and still be able to register and make phone calls, for that scenario, you want to set the NAT traversal to auto. So when the phone detects that the SIP server is located locally, it's not going to use the stun server. However, when you take it home and it detects that the IP phone is trying to register to a public IP address, then it's going to initiate the stun request. And the stun request works this way. The endpoint device will send a binding request to the configured stun server asking about its public IP address. Then the stun server will respond back with the public IP address, and that's the information that the IP phone uses to communicate with the IP PBX. And that information is especially used for audio. So if you have a remote phone that is able to register, make calls, but you're still experiencing issues with the audio, stun configuration could be one of these issues or one of the things that you need to look at and fix. So let's log into one of the IP phones. Yeah, let's use this one, 2170. So this is an example of how to configure an IP phone for hybrid work from home. You can include the primary SIP server as the private IP address of the IP PBX, and then include the public IP address of the IP PBX so you can register when you take the phone home. Save and apply the changes. Then you go to network settings. Then you have some options here. We don't want to use stun because if you use stun in a local environment, that might create issues with audio. So we want to set that one to auto. You can choose stun if this phone is a remote phone. It is like you're not going to bring it back to the office to work with the IPPBX locally. You can do that. You can use stun. But for hybrid work from home, we want to set that one to auto, save and apply the changes. Another thing when you configure network settings for auto or stun, you just need to go under general settings, I believe. Yes. And the stun server, you need to configure the stun server. You can use the Grandstream one, which is IP video talk. I'm missing V here. ipvideotalk.com. So when you configure stun server, save and apply, then reboot the IP phone because stun works after you reboot the IP phone on specific devices. So let's go back to the account again. So if you go under SIP registration, basic settings, we talked about SIP expiration, sorry about that one. So by default, it's set to 60. So you can always set that one to 4. The reason why we want to reduce the SIP registration to a lower value because some routers, they have a NAT table that they only maintain for like 10 minutes or 8 minutes. So when you use the registration for 60 minutes, that means the phone we need to re-register like half life of the registration timeout, which is 30 minutes. Okay, so by the time the phone tries to register to the SIP platform, if there is an incoming call, the router might block that that call because there is no established connection in the NAT table. So we want to reduce that one to 4 so we can keep the router always updated. Subscribe for expiration. You can also use that one in case you are using BLF. Like if you notice that you have a remote phone that keeps losing BLF or it doesn't show the correct status of BLF, you can also use that one because the UCM to notify the phone that there is a change in the status of one of the monitored extension, it needs to send a SIP notify to the IP phone. And if the router blocks that SIP notify, the phone will eventually show an incorrect status of that extension. Let's look at some other options here. Now, and for security purposes, in case you want to do that, as you can see in my IP phone here, for especially for the first account, like account one, because by default it's using 5060, I usually change that port to a different port because the hackers who scan the networks, they use 5060. So when your IP phone is located remotely and it establishes a connection with the server using port 5060, if your router doesn't have like an enhanced security mechanism, it will eventually allow those scanning messages to hit the phone, and you will end up having a lot of ghost calls. So you can change that one to a different port. You can use, for example, 8060 if you want to. Some other options, there's also security settings here. In case you don't want to use this option, you can also use this one right here. These are the two options that I would usually recommend to implement for remote IP phones so they don't get those ghost calls or phantom calls. Check SIP user ID for incoming invites and accept incoming SIP from proxy only. You can also add this option, but it might not work with some third-party SIP servers. So this one only works with the Grandstream. I won't say only works, but only works with the IP PBXs that accepts challenge from SIP endpoint. So I'll set that one to no, then just save and apply those changes. The other thing, we talked about this earlier, which is the vocoder. Some routers, they can't handle IP fragmentation. So when an IP phone sends an invite and it includes all this media, it increases the size of the SIP packet. So one of the options that you can do is, for example, if you know that your SIP server supports PCMU, you can set all of these to PCMU so that the phone doesn't negotiate for all these codecs. It will just send PCMU alone in the media message. And one of the symptoms uh, that you might experience if you have an MTU size issue on the router is that you dial the number and then you see that the call just hangs in there. It's like it keeps saying connecting or something. The phone is not ringing or anything. You don't get the ring back tone, but after a time it will disconnect the call. So that's one of the symptoms, and this only works with outbound calls. The reason why, because when you make an outbound calls, the server will challenge the IP phone to provide authentication. So when the IP phone adds the authentication, which is the nonce and the hash and the digest, the size of the packets increases, and that causes the outbound calls not to work in specific environments. So that's one of the things that you can do. You can change all of them to the same codec to reduce the size of the packet. So I believe we covered all the settings. If you guys have any questions, please use the Q&A section or the chat. I don't see that many chat though. So we still have a few more minutes. We still have like 8 minutes in case you have any questions regarding today's presentation. So James is asking, can they give us the ability to add max to gaps? So as I mentioned, James, earlier, you just need to contact your supplier and check with them if they provide access to gaps, because gaps is handled by our distribution channel. So just call them and check with them if they can provide you with the access to gaps so you can start managing your devices from that profile. Uh, James is also asking, secondary SIP is the internal private IP from the router, the HCP. The secondary SIP, I'm talking about the server, because the servers usually when they are in a local network, they have a private IP address. But in case you want to register remotely, you need to configure port forwarding or assign a public IP address to the UCM so that devices can register from the public network to the device. So that is why I recommended to use the private IP address for the primary SIP server and the public IP address for the secondary SIP server. Jeffrey, where can we find this video? Jeffrey, the recording for today's webinar will be posted on YouTube, I believe, before the end of this week. So you can always check in Grandstream YouTube channel when the video is uploaded. All right, I don't see any more questions. Thanks everyone for attending today's webinar, and stay tuned for the next webinars that we're going to host in the upcoming months. And again, thank you and have a great day and stay safe.